Assalamu alaikum, dear students. Today we are going to talk about an important thing about these quadrilaterals. Okay, if you remember in the last video lecture we talked about quadrilaterals and its types. Okay, one of the major types of quadrilateral was parallelograms. Okay, today we are going to discuss something more about these parallelograms. Okay, that is elements of parallelogram. Okay, we'll write here elements of parallelogram. Elements of parallelogram. Okay, what is this all about? Elements of parallelogram. Suppose this is a parallelogram. See, this is the what is parallelogram all about. See, this is a parallelogram. Okay, you know the properties of parallelogram. Say for example, this is vertex A, this is vertex B, this is vertex C, and this is vertex D. Right. See, what is this elements of parallelogram all about? You know that a parallelogram has four sides in which both the pairs are parallel, means this side is parallel to this side, that is AD is parallel to BC, and AB, this side, that means AB is parallel to DC, right? So we can say that this AD and BC are opposite sides. So means first element of this parallelogram are its opposite sides. So opposite sides are AD and BC. So the opposite sides, and AB, this side, and this side. These are two other opposite sides, AB and DC. Okay, then this is the first element of opposite sides. Then see, if you can see here, it has also got four angles: angle A, angle B, angle C, and this is angle D. And you know that in parallelogram opposite angles are equal. So that means this angle D is equal to angle B, and this angle A is equal to angle C, this angle, right? Okay, so these are the four angles of a parallelogram. Okay, so we talked about what are the opposite sides. Parallelogram, see, this is a parallelogram. See, this is a parallelogram. This side, these two sides, so that means A, B, C, D. AB, side AB and side DC are two opposite sides, one of the pair of opposite sides. And similarly, this AD, side AD and side DC are two opposite sides. Okay, now this side AD and DC, since for example this AD starts from this A, it ends at D, and this DC starts from the point where this AD line ends. So these two sides are called as adjacent sides. So adjacent sides, adjacent AD and DC are two adjacent sides. DC, this DC and CB, DC and CB are two other adjacent sides. Similarly, CB and BA are another two adjacent sides. Then AB and this AD are another two adjacent sides. Okay. So one of the elements that we talked about was opposite sides, and the second was adjacent sides. Okay. Then there is number third element of this parallelogram, that is, okay, see, for example, again this is a parallelogram. Say for example this is a parallelogram. Okay, see this angle and this angle, these are two opposite angles. Say for example A, B, vertex C, vertex D. Angle A and angle C are two opposite angles. Okay, then this angle B and angle D are two other opposite angles, right? Okay, then similarly we can talk about the adjacent angles. See this angle A and angle D, since they are formed by the same line segment, since they share one of the line segments. Say for example this is angle A, this is angle A, right, and this is angle D, right, this is angle D, right. Angle A and angle D share the line segment AD, so we can call these two angles, angle A and angle D, these are called as adjacent angles. Okay, similarly angle D and angle C, these are two other adjacent angles. Okay, in the same manner angle C and angle B are two adjacent angles. Okay, so these are called as adjacent angles. When an angle and two angles share a line segment, those angles are called as adjacent angles, right? Okay, now these are some elements of a parallelogram. So now you know that the opposite sides of a parallelogram. You also know that the adjacent sides of a parallelogram, adjacent angles, and opposite angles of a parallelogram. Now there is another important thing that need to be discussed, that is, see for example this is a polygon called as pentagon, right? So we know that some of the angles, some of the interior angles of a polygon, that is 540. What about the sum of the external angles? Say for example this is a pentagon. Okay, this is its one of the external angle. This is another external angle. This is another external angle. This is another external angle, and this is another external angle. So we have to find out the sum of the external angles of a polygon. See, say for example if you start here, right, then you have to move in this direction to reach this spot, this vertex. For example this is A vertex, this is B vertex. Okay, then from B vertex you have to move in this direction in order to reach this vertex C, right, then vertex D, then vertex E, then finally you reach the same position where you have started, right, then the vertex C. If you can see that you have moved by a complete angle, right, so that is 3 complete angle measures 360 degree, right. So we can say that sum of exterior angles of a polygon is equal to 360 degree, right. Okay, this we can prove also. Say for example this is a again I will take the pentagon. So this is a pentagon. Say for example this is a regular pentagon. Okay, by regular pentagon I mean to say that when the pentagon is equilateral and equiangular, that means this side is equal to this side, equal to this side, all the sides are equal and all the angles are equal. So for that the measure of all the angles is same, So that means we know that sum of the interior angles of any polygon, be it regular or non-regular, that is 540, right? 540 degree. So can you find out the measure of a one angle? So what you have to do, since this is a regular polygon, you have to divide 5 because there are 5 angles. So 5 ones are 5, 5 ones are 5, 5 zeros, 5 eights are. So measure of each angle is 180 degree, right? So measure of this angle is 108 degree. Okay, this angle is also 108 degree. This angle is also 108 degree, and these two are 108 degrees in measure, right? Okay, I will redraw this pentagon. Say this is a pentagon. So this is a pentagon, right? So measure of this angle is 108 degree. This angle 108 degree. This 108. Okay, all each angle of a regular polygon, that is 108 degree, right? Okay, so let me find out the measure of each external angle. So I will extend this line segment in this way, then I will extend this line segment in this manner. I will extend this line segment in this manner, okay, and this line segment in this manner, and then this segment in this manner, right? So what is the measure of this angle? 108 degrees centigrade, this angle. And you know what do you mean by the linear pair of angles? Say for example, this is a line segment. What is the measure of this angle? This is 108 degree. If we divide this angle, for example, two line segments, now these two angles, this plus this, is equal to 108 degrees centigrade. 108 degree, sorry, 108 degree, right? So now, so if this is 100, this if you can, if you concentrate on this point, okay, this angle is linear angle, okay, so its measure will be 108 degree. Since it has been divided into two parts, look at this line segment, so this part is 108 degree, the remaining part will be 72 degree. 72 degree. So 108 degree plus 72 degree, that is equal to 100. Similarly, this is 180 degree, and the measure of this angle will be 72. Similarly, this 72. Similarly, this 72, and the measure of this angle will also be 72 degrees centigrade. Right. Degrees centigrade. Right. Now, what we have to do is to add up these external angles, 72 plus 72 plus 72 plus 72 plus 72. That means 72 into 5. So that is equal to, this is 5, right? 72 into 5. So 72 into 5 is 5 2 are 10. 5 7 35, 36 degrees centigrade. So here we can say that sum of the external angles of any polygon, be it a quadrilateral or be it a pentagon, hexagon. If we talk about the hexagon, say for example, I will draw the hexagon here. See, for example, this is a hexagon. Say for example, this is a regular hexagon. Okay, so the measure of each angle of a regular hexagon is 120 degree. 120 degree, right? Then let us suppose we have to find out the measure of external angles. So what we have to do, we have to extend this line segment, this line segment, this line segment, this line segment, okay, and then this line segment. If this is 120, the remaining part will be 60. Same is the case here. This will be again 60. This again 60. This again will be 60. Right. This again will be 60, and this again 60 degree. Right. So how many angles, external angles are formed there? 1, 2, 3, 4, 5, 6. So that means 6 into 60 is equal to 360 degrees. So here again we can say that the sum of external angles of a polygon, what is called as hexagon, okay, that is 360 degree. So the point is sum of external angles of any polygon, be it a quadrilateral or be it a what is called as pentagon, hexagon, or a polygon of any side, that is equal to 360 degrees, right? So you have to remember this. Okay, so this finishes our today's topic, right? Tomorrow we will come with another important topic.